Hi guys, in this video we will see how to print helical or spiral matrix of any size. For illustration purpose I have taken 5 by 5. So the spiral matrix is something like this. It will start with 0 0 and end with the center of the matrix. Okay. So the arrangement of element is something like this. It has to be 1 2 3 4 5 and then 6 7 8 9 and then 10 11 12 13 14 15 16 and then 17 18 19 20 21 22 23 24 25. So the center element ends with 25. Because this is a 5 by 5 matrix, we can accommodate 25 elements, right? 1 to 25 in the spiral manner. Okay, now let's try to program this. For this, let's go to our code pad. So let me take printf, enter the spiral matrix size. Okay, scanf, because it is a square, one side is enough. Let me take this. Okay, now let's write one method, print or generate spiral of size. Let's write this method, void generate spiral int size. Okay, and we will take one array called spiral of size, say 100 by 100. So how we will do this? Again, let's go back to our example. I will decipher this big problem into 4 smaller chunks. As you see, there are 4 rectangles here. One is in red color, second one is in green, third is blue, fourth one is in brown color. So first I will try to generate this first red color numbers using one for loop, then the green color numbers using the second for loop, blue color numbers using third loop, finally brown color numbers using fourth loop. Let's write those 4 loops. Okay, now I will take current row and current column. Let's initialize both to zeros. Let's take one more variable called counter. Initially it will have 1. Let's write the first loop for the red color one. For red color numbers, the row is constant, that is the current row, the otherwise 0th row, and column will be changing, keep changing, right? So let me write code for that. Int row, row is constant, columns will be changing. So columns, let column equals to 0, column less than size minus 1, column plus plus. Okay, spiral of, so here I said like row is constant, that is current row, and column will be changing, and the counter we have to keep increment and assign. So we are done with the red color rectangle. Now let's write code for the green color one. Okay, so here column is constant and row will be changing. So let's do that. For int row equals to 0, row less than size minus 1, row plus plus. Okay, spiral. So as I said, like column is constant here, row will be changing. So row and the column will be size minus 1 and the counter will be keep incrementing and assigning. So this is for green color. Now let's write for the blue color one. For blue color one, row is constant and columns will be decreasing. So let's write int columns equals to size minus 1, column greater than 0, column minus spiral of row is constant, I said, right? Row is size minus 1 and column equals to counter plus plus, right? And finally lastly write the for loop for this brown color numbers. So here column is constant and rows will be decreasing from the bottom to top, right? So brown color numbers for int row equals to size minus 1, row greater than 0, row minus minus, right? Spiral of, so column is constant, row will be changing, so row and column will be current column. Okay, I can use the current column, right? And counter plus plus. So with this we have done with the number starting from 1 to 16. Okay, now I will reuse the same logic for the inner spiral as well, because this is after all one more square, but the starting number will be 17 and ending number will be 24. So 17, 18, 19, 20, 21, 22, 23, 24. So I can reuse this outer 4 loops, right, with increasing row number, because initially row number is 0 but the row number will be 1. Similarly column number will also be incremented by 1. So let's do that. By the way, let's take one while loop here. We have to increase the current row up to size by 2, right? Half of the spiral is enough. That's why I have taken a loop with current row size is less than size by 2. Let's align this code a little bit for more clarity, readability. Okay, so as I said, like for the inner spiral we have to increase the current row, also current column. Okay, now with current row current column will be 1, will become 1 1. Initially they are 0 0, right? Now they will become 1 1. Now the first for loop for the red color numbers has to start with current row, right? And it should go up to size minus 1 minus current column. Okay, so let me change this for loop slightly. So I will say current row. So this will hold for the first outer spiral first row as well, right? Because that time current row is 0. Now it will be current row will be 1. So and then here we have to column size should be up to size minus 1 minus column size minus current column. Okay, and column plus plus. So this will do the rest of the magic. Now let's target for the second for loop, which is for green numbers. So here it has to fill 19 20, right? This has to be current row. Initially it was 0 but now it should be 1 because it has to start here. So the row current row will be 1. So let's use the current row here, and row should be called size minus 1 current row. Okay, because it has to go up to 20 only. So for that we have to make it row size minus 1 current row and row plus plus. So rest so here also size minus 1, instead of size minus 1 we have to say current row. Let's look into the blue color one. So blue color one will be 21 and 22, right? So here the column will should start from size minus 1 minus current column, and column should be greater than current column, and column minus minus. Here also we should do current column. Then it will do the rest of the magic. Finally the brown one should be like this, 23 and 24, right? So again current row, and row should be greater than current row, row minus minus, and anyway we have used the current column, so this is correct. Okay, counter plus plus. So that's it, we are done with the entire spiral matrix. We have to now just print the matrix. Let's print it, and for each row we have to introduce new line feed. So that's it. Let's try to run and see what is the output. let's do for 5. So you see 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. So we are missing with the last number 25, right? I will accommodate that, but let's try to run it for 6 of size 6. So this is correct, right? So for even numbers this is working perfectly fine. Let's give 4, so 16, this is good. Let's give 3, so 3, the middle element is getting missed. So just have this spiral row size by 2 size by 2, no, equals to counter plus plus. This we have to do only if size modulus to odd. For odd cases we have to do. Okay, for even cases no need to do this. Now let's print for the 3, this is correct. Let's print it for 5, this is also correct. Let's try for some even number, and this is already working fine, now also working fine. So that's it. So this is how we will generate the spiral matrices. I hope the code is clear. Let me know if you have any doubts through your comments. Thanks for watching this video.